So welcome to all of you. Today we will learn the another data preprocessing concept, that is the outlier detection and the removal of the outliers.
Now let us discuss about outlier and missing value. So when data is collected, there is a chance of some abnormal values creeping into the data. For example, we are collecting it is a 7. We are collecting the height of, let's say, this 7 student in class 10, right? So the values are let's say it is like this. So if you observe these values, so I mean this value 7 seems to be abnormal, as it is more likely not possible for the class 10 10th standard students, right, having a height of 7 feet. So this is due to the mistake maybe done by the typist when entering the data. So he would maybe he would have entered the value 7 while actually it may have a value like a 5. So this value 7 is actually called as a outlier. Now the problem with the outlier is that they modify the final conclusion, maybe the result, so which can be drawn from this data set. For example, let's say we want to find out the average height of 10th class student based on the data. So we will have a lots of difference in the average height with and without outlier. So let's say this A is a list which is having this abnormal data where this outlier is existing. So what I'm doing is I'm trying to find out the average height of this 7 student, right? So if I will find out the average height, so we have to add all this number divided by the length. So if you print it, so the average height of 10th standard student should be tall, I mean they should have a height of around 5.5 foot, right? That is not very appropriate for the 10th standard student. Whereas if you have not included the outlier, then the average would come as 5.2. So 5.2, I mean that is a very much accurate, right, for the 10th standard student. So what I want to say here is, if there exists the outlier, the entire conclusion may be changed. For example, here in this case, if you see that in presence of outlier, it is giving you the result that 10th standard student should have a height should be around 5.5 inch, whereas that is abnormal, right? Actually, it should be around 5.2. It is seems like a very appropriate for the 10th standard student. Now, concern comes what is the cause why we are getting this outlier, right? So there may be several reasons, right? That may be due to the incorrect entry. So maybe after collecting the data, while it is being entered into the computer, the operator would have entered it incorrectly or wrongly. Maybe the typist has done the mistake. It should be like a 000 and the typist has made it like a 1000. So that may be the possible, right? So that is due to the incorrect entry. It may be happened due to the misreporting. So when the data is collected, some people may provide the wrong data intentionally. For example, if you see that the boys may exaggerate their salary in over the matrimonial sites. So sometimes this outliers comes due to this misreporting reason. Now other reasons may be the sample error. So let's say while measuring the height of Bengalis, we might have taken the heights of some Punjabis into the sample. So as we are knowing that, let's say Bengalis are a bit short, but when we mix Punjabi height who are taller, then the calculation of Bengalis height may not be accurate, right? So that is due to the sample. Now one more reason would be that is exceptional but true. Maybe the sometime outlier may be correct, but they are the abnormal. For example, the average income of people in USA may be in range of, let's say, $40,000 to let's say $60,000, but income of Bill Gates may be around $1 billion, which when added will affect the overall result, right? So number of reasons it may have, and number of causes it may have due to this due to that outlier creep into the data. So now concern is if let's say outliers are there, then how to detect it and then how to handle it. So that part actually we have to learn. So for that regard, I have taken this data. So this data is available over the Kaggle. So this data set basically contain data related to the solid waste management in the state of USA for 15 years. I mean, it was starting from 2000 and to 2014. So the data about the waste from agriculture used in, aluminum cans, anti-fridge material, appliances, white goods, ash, sand, dust, right? Asphalt production, and then the concrete, and these are the features are available in this data set. So this data set has a 15 rows and 18 column like this. We are having this information with us. Now, if you want to visualize the column name, that you can visualize like this, df dot column. If you hit this, then all the column names you will get. If you want to transpose it so that we can visualize the values properly, so you can transpose the data frame and you can take the glance about the data frame, right? So for that regard, I have done this transpose. Now concern come, if outliers are there, then how to detect it? So in this this data set, we want to detect the outlier in only one column at a time. So actually this is called as a univariate analysis. So basically in univariate represent only one variable or one column at a time, right? So there are basically these three ways are major ways are there to detect the outlier. One is we can go with the sorting of the data, or we can draw the graphs or plots, or there is another way to detect the outlier is interquartile range, right? So let us learn this thing one by one. Let's say identify the outlier by using the sorting. So basically the outlier contain the values that are very low or very high. So this is the reason they are called abnormal values. So when we sort the data into the ascending order, we can have a data started from low values to high values. So if outliers are there, and if outliers are maybe very low value, then they can be seen in the beginning of the sorted data. If outliers are very high value, then they can be seen at the end of the sorted data. So this clue helps us to sense the outlier, right? So with these assumptions, we can apply this short value. Suppose we want to find out the outlier in the column called aluminum cane. So we have to first sort the data set on that column. So we are sorting it, right? So if you perform this sorting, this would be the outcome of that. Now let us observe the first 5 rows by displaying them. So this is the outcome of that. Now this above row represents the row index number and the value of aluminum cane, right? Now the difference between first value and the next value, 12,540 and 12,718, right? So there is a difference of around, it is around 178, right? So this is a normal when compared to the difference between the other rows, right? Now the difference are ranging from, let's say, 200 to 600, right? Now let us display the last 5 row, right? So if you display the last 5 rows, so you may see here, if you observe the difference between the last row and its previous row, see these two value, right? So here the difference are coming like maybe 3000 plus, right? 3154. So this is the abnormal difference, right? The difference between these two entries are abnormal. Hence, you may say that this last value 21,098 at the index number 9 is considered as an outlier, right? So that is one way through which we can identify it. Now, other way is by using a plot or graphs, we can visualize it, right? So, drawing the various graph or plot will also help us to detect the outlier by their visual examination. So, when compared to the remaining data, the outliers are represented as a separate data point, right? These are the separate data point you will see over here. Now, which would be distant from the other data point. So if you see this, the outliers are displayed using this 3 different graphs. So in a box plot, the outlier can be shown either above or below the box. So it is above this U1. So these are the outliers. If you see the histogram, the outliers are displayed as a bar far away from the other, this beans, right? If you see the scatter plot, it is also known as a QQ plot. So in a scatter plot, the outliers will be seen as a data point away from the group of other point, right? So by using this plot also, we can visualize, we can detect the outliers. So to find the outliers in the aluminum cane column, we can draw a box plot using this box plot function of the Seaborn module. So if you draw it, so by seeing this plot, you can observe that data point away from the box plot, so at the right side, so we can understand that outlier is at around you may say at around 21,000, right? Now let us now display the distribution plot using this plot method, this plot function, right? That is available in this Seaborn module. So if you see this distribution plot shows the number of bars by default. So if we will observe it, so we can understand that this isolated bar around again 21,000 should be treated as outlier, right? So another way which we can use for detecting the outlier is IQR. So this IQR represents the range of value between 75 percentile and 25 percentile. So we can divide the total data into 4 parts, maybe 4 quartile you may say. At let's say it is a 25 percentile, there is a Q1, there is a 50 percentile that is called as Q2, 75 percentile is called as a Q3, and 100 percentile is called as a Q4. Now the difference between Q3 and Q1 is actually called as IQR, right? So basically Python offer a method called quantile, right, to calculate the quantile value in percentage, right? So here we have to pass the parameter as a percentage. So we have to pass this percentage value as a parameter to this quantile method. So if you want to calculate the third quartile or 75 quartile, then we have to use the quantile 0.75. That parameter we have to pass into it. Similarly, if you want to calculate the first quartile, we have given this value, we have passed this 0.25 as a parameter to this quantile method, right? Now after calculating this Q1, Q3, we can find out the value of IQR. So IQR is nothing but we have to subtract Q1 from Q3, right? So this will give you the interquartile range. So if this IQR actually will help us to find out the valid upper and lower limit in the data set. That is the importance of IQR. So the valid upper limit should be Q3 plus 1.5 times IQR, right? That is a upper limit. Whereas if you want to find out the lower limit, then it should be Q1 minus 1.5 times half times of IQR, right? 1.5 times of IQR. So by that way, we can figure out the value of U1 and L1, upper limit and lower limit. So using this, this formula, we can calculate the upper and lower limit. Any value above the upper limit and below the lower limit should be considered as outlier. So any value which is above this 20,798 will become an outlier, and any value below this 8,920 will also become an outlier. When we observe the data set, so we may understand that there is only one value that is above 20,798, and if you see that that value is nothing but this one, 21,098. It is above the this upper limit, right? It is above the this U1 limit, right? So that should be, this value at the index number 9 should be treated as outlier. So that is a that is the inference we got after this analysis. Now concern comes, if you have detected the outlier, then the next concern is how to handle this, right? Now we have figured out that outliers are existing, right? At the index number 9, that value is around 21,098. Then how to handle it? So for that regard, we are having an approach like either we can delete them or we can replace them with some reasonable value. So when data set contain the huge number of rows, it is better to delete the outlier. When data set contains less number of rows, then deleting the outlier will affect the result, as the number of available rows after deletion will become a little lesser, right? So let us first see how to delete the outlier from the data set. So we have to delete the rows with value above u1 and below l1. So this can be done using a numpy, and we are having a numpy where function that returns an array of index, right? So that that we have to give, right? So it is going to be return you the array of index, right? So to find the upper bound value that are above u1, right? For that regard, we have to execute this statement. Now to find out the lower bound value that are below L1, we have to execute this statement. Now in this two statement, with the help of this two statement, upper and lower represent basically this one dimensional array with the index number of rows to be deleted, right? So we can observe that if you execute this one, this upper contain the index value as 9. That means ninth row contain the outlier that need to be deleted. Now we have to delete those rows. So we can do it by executing these two statement, right? So I have not executed it. The reason behind it, I want to include it so that I can show you how the imputation can be done, right? So I have not done it. If you want to delete, you can delete it. But again, remember that if dimension is high, then deletion is having no issue. But if there is a limited number of rows, then this deletion is not a good idea, right? So that part we have to keep in mind. So now with this, if there is a limited number of rows, then it is better to replace the outlier with the reasonable value, right? So generally outliers are replaced by the mean, or you may say the median value of the other value in the column. So we know that the numpy module has a function called mean and median to calculate the mean and median value. Suppose we want to calculate the median value, so we have to use this median function, right? So we are calculating that over here, this median function, right? So what we have to do for that? So first of all, we have to convert this aluminum cane values into array using this dot values attribute. So now after that, all these values of array should be between lower and upper limit. So such values are marked as the true, which is satisfying this condition. Remaining values which are not satisfying the condition, it means they are the outliers. So that I am replacing by the false, right? So we can observe that there is only one false. There is only one false in this, right? That is at index number. It is a ninth, right? Ninth position. So this is my outlier. So to replace this row with the median value, let us find the median value of all the true values, right? So I am finding out the medians of all true value. So we know that outliers are represented by this false. To replace the outlier with the median value, we have to replace the false index by the median value, right? So this median value is keeping over here, that I am replacing by this median. So once we execute it, now that outlier value which was present at the index number 9 in aluminum cane, the value of that was 21,017.8, that was replaced by this value 14,157. That was a median value. You may see this was our median value, and the outlier was present at the ninth index, so that I am substituting by this updated value, right? So at the ninth column, now this value was replaced by the median value, right? So it means that this outlier which was present in aluminum cane is now free from that outlier is not free. This column is free from the outlier after performing this operation. So that is the idea behind this outlier detection and removing of outlier. One more problem which we used to face frequently, that is the missing value problem. So in real world, basically the data set are not clean and may have a missing value. So we must know how to find and deal with this this missing value. So one of the strategy to deal with the missing value is to remove them from the data set, right? Either you delete this row, you delete this row, or you delete this row. But that is not a good idea if there is a limited number of rows. So I mean, whenever it is possible, we should impute the data, right? Which is the process of filling the missing value. So here we will discuss how to find the missing value basically, and how to remove them. That strategy we will learn. So I'm using a data called this auto MPG data. So this data contain the information about the different cars and their characteristics, such as MPG, that is a miles per gallon, number of cylinders, that is a number of cylinder, and I mean this values is ranging from 4 to 8, the displacement, horsepower, weight. So horsepower is basically a continuous variable, right? That is specifying the engine horsepower. There is a weight, that is a vehicle weight, right? And acceleration, time to accelerate from 0 to 60 maybe mph, right, in second. That value is there. So this information is actually we have obtained from this, so that this data is available over here. So you may get the description of all this column from there itself. So basically the data, this data set contain space separated value, and there is a no header, right? So to read this data set onto the data frame, we have to use this pd.read_csv method, and the separator should be the space, and we have to set header as a none, right? So as I told you, as the data set does not have a header, so the columns are not named over here. We can name the column by assigning the list of name to the data frame header. So these column names are given in the data set description. If you hit this, you will get the description about this column names. So what I'm doing here is we are going to create a list of above names and assign to the data frames column attribute. So we are assigning this value to our existing data frame. So after executing it, now this would be our data frame. This is our updated data frame, which consists the data as well as the column name. Now, if you see this properly, so after creating this data frame, I have find out the info. So here, important part is here the horsepower column has been inferred as object, whereas it should have been inferred as a float 64. This may be because of some of the row contain non-numeric value in the horsepower column. So one option to deal with this to force convert the horsepower column into numeric, right? That is one way. We should convert the non-numeric value into null value, and we are having a method called pd.to_numeric can be used to convert any column with the non-numeric data type to column with the numeric data type, right? So that is the purpose of this method. So basically it takes the parameter called error, now which specify how to deal with non-numeric value. So I mean there is a following are the possible parameters which we have to pass to this method. So in our case, what I did, we use this error called course. So basically convert any non-numeric value into NaN, right? So that I did. So after executing this statement, you may see this horsepower column has been converted to the float, whereas earlier it was the data type of horsepower was object, right? So now we can verify it. If some of the row contain a null value in horsepower column, this can be done by using a isNull method on the data frame column. So what I did, I am displaying that null values are there or not. So you may see after executing this statement, there are 6 rows which contain null value. This row can be now this how to handle it. This row can be dropped from the data frame using a method called drop NA. So basically drop NA method remove all the rows with NaN value. So in this data set only a feature horsepower contain this NaN. Hence we have to, this under the subset argument, we have to pass this column name horsepower. So if you execute this statement, now we can verify after that if the row with the null value have been removed by applying the filtering condition or not. So if you execute it, you may see none of the rows are having a null value. Now filtering with the isNull shows that no row with the null values are there anymore. Similarly, we are having a method called fill_na. So fill_na can take the default value to replace the null value in a column. For example, fill_na 0 replace all the null value in a column with the value is equal to 0. So that also we can check.
Now let me summarize what we have learned in this analysis. So this outlier basically are the abnormal data points that are distinct from the normal data. So this outlier can be detected by simply opting the sorting technique over the data. So basically when data is sorted, outlier can be found either in the beginning or at the extreme ending of the data. So this outlier basically can be displayed as a data point away from the normal data point in the graphs or plot. So this technique will help us for detecting the outliers. So we also use the interquartile range, that is also known as IQR method. So basically this method shows upper and lower limit of the data. So the data point not in this limit will be treated as the outlier. So this technique also help us for detecting the outliers. Now the concern is, due to this outlier, the final results or conclusion drawn from the data is not be correct, right? That's why this detection and the removal of outlier is very much important. So we have to remove the outlier from the data set, or we have to replace them with the suitable value if you want to get a better result from the models. Thank you.